See, coming to what are the subtopics in the linear algebra we are having. Subtopics in the linear algebra. Types of matrices. Types of matrices, and second one it is the rank. System of linear equations. System of linear equations. So what are the linear equations we are having? System of linear equations. So what are the linear equations we are having here? Two types of linear equations, as all of you know. Homogeneous equations. Homogeneous equations and non-homogeneous equations. See here, totally types of matrices, 30 different types of matrices you have to study. 30 different types of matrices along with the conditions, example problems and all. This is the biggest topic. Types of matrices is the biggest topic. Then the rank. What are the methods we are having for the rank? One is the determinant approach. One is determinant approach, and second one it is the echelon form. Homogeneous equations, non-homogeneous. How to identify homogeneous and non-homogeneous? A1x plus B1y plus C1z is equals to 0. A2x plus B2y plus C2z is equals to 0. A3x plus B3y plus C3z is equals to 0. And coming to non-homogeneous, A1x plus B1y plus C1z is equals to D1. A2x plus B2y plus C2z is equals to D2. And A3x B3y plus C3z is equals to D3. So what is the difference between homogeneous and non-homogeneous? If you are observing, right, what is the difference? You can identify easily. If all elements are the zeros in the right hand side, then it is a homogeneous. At least one of the right hand side is non-zero, it is a non-homogeneous. So homogeneous and non-homogeneous also very important. Sometimes 2 marks bit also will be expected from this topic, system of linear equations. And what are the different words associated in the system of linear equations, like consistent, inconsistent? So we will discuss what are the definitions of consistent. Consistent means what? Which contains a unique or infinite number of solutions. Inconsistent means no solution. And what is the meaning of the trivial solution? All these concepts will be discussed in the system of linear equations. So system of linear equations, only one method is there for us, that is a rank approach. No need to worry about the Gauss method, Gauss-Seidel method, iteration method. There are two different methods are there, no need to go through that. Only rank approach is enough for you. So that is the third topic, is system of linear equations. What is fourth subtopic in the linear algebra? Characteristic matrix. Characteristic matrix. Characteristic matrix. So what is the definition of the characteristic matrix? A minus lambda I. All of you know, for a given matrix A, what is the characteristic matrix? A minus lambda I. Characteristic equation. What is the characteristic equation? Determinant of A minus lambda I is equals to 0 is the characteristic equation. Next, and coming to fifth topic, eigenvalues and eigenvectors. Very important. Eigenvalues. What is another name of eigenvalue? Is also called characteristic root. Eigenvalue, characteristic root. Eigenvalues, characteristic root, latent root. Eigenvalues and eigenvectors. What are the eigenvectors also we'll study. Eigenvalues, eigenvectors is very important. So around here we will discuss around 17 properties. All are very important. So like sum of the eigenvalues is the trace, product of the eigenvalues is the determinant, eigenvalues of the triangular matrix, scalar matrix, diagonal matrix are the principal diagonal elements. One of the eigenvalue of the singular matrix is 0. Eigenvalues of the real symmetric matrix are always real. Eigenvalues of the real skew symmetric matrix are either zeros or purely imaginary. So like that we have more than 17 properties. They are all very important. So one of the definite type of topic eigenvalues and eigenvectors. Sixth one is the Cayley-Hamilton theorem. Cayley-Hamilton theorem. Cayley-Hamilton theorem. What is the purpose of the Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. Cayley-Hamilton theorem. So up to 6 are very important. Up to 6 topic they are all very important. The gate point of view. So whatever the 7th and 8th I am going to give, they are all not much but sometimes. LU decomposition. LU decomposition, one small topic. And linear dependent and independent of vectors. Linear dependent and independent. Linear dependent and independent. Linear dependent and independent of vectors. So first 6 topics are very important. What are the 6 topics here? First one is what types of matrices. Near about 30 different types. Rank, determinant approach, echelon form. System of linear equations, homogeneous and non-homogeneous. And then next characteristic matrix, characteristic equation, eigenvalues. Another name of eigenvalues is a characteristic root, latent root. Eigenvector, another name is what? Characteristic vector also you can say. Characteristic vector. Okay. Then Cayley-Hamilton theorem, LU decomposition, linear dependent and independent of the vectors. So all these 8 subtopics covers for us 2 to 3 marks. Let us go to our first topic. Yeah, all of you know what is the first topic is the types of matrices. Types of matrices. So this is a little bit lengthy topic. So today entire session is with the types of matrices and it will extend tomorrow also some next time. Types of matrices. What is the definition of the matrix? Matrix definition. A rectangular array of elements. A rectangular array of elements. Rectangular array of elements arranged in horizontal lines. Rectangular array of elements arranged in horizontal lines and vertical lines. Horizontal lines and vertical lines. So little bit patience is required. We have to attend everyday class and up to the end of the every topic. Then only you can score the whatever the 3 marks from the linear algebra. A rectangular array of elements arranged in horizontal lines and vertical lines is called the matrix. Horizontal lines are called what? Rows. Vertical lines are called the columns. So general form of the matrix. If you want to write the general form of the matrix. So what is the general form of the matrix here? A11, A12, A13 and so on. A1n, A21, A22, A23 and so on. A2n. And what is the last row? Last row it is a AM1, AM2 and so on, AMN. Yeah, this is the general form of the matrix. How many rows we are having? M rows are there and columns are n columns, m by n. This m by n is called, what is the name of this m by n? Yes, can anybody guess what is the m by n? What is the m by n is called? You can type now. Yes, anybody what is the m by n is called? It is the order of the matrix. M by n is the order of matrix. M by n is the order of the matrix. Number of rows by number of columns. Yeah, all of you know. Order of the matrix. Order of the matrix. Number of rows by number of columns. So if you take some examples here, 1, 2, 3, 4, 5, 6. What is the order of the matrix? Number of rows are the 2, columns are the 3, 2 by 3. 1, 2, 3, 4, 5, 6. What is the order of the matrix here? Number of rows are the 3, columns are the 2, 3 by 2. That is the order of the matrix. Some examples. Next, very important notations here. Important notations you have to follow. What are the important notations we have? I, J, M, N. These four notations are very important. I, J, M, N. I represents single ith row. I represents single ith row. J represents single jth column. M represents number of rows. M represents number of rows. N represents number of columns. So all these important notations are very important. So here I am going to give an example. What is the significance of IJMN? A is equals to Aij with 3 by 3. A is equals to Aij with order 3 by 3, where Aij is equals to I minus j. Aij is I minus j. Then what is the matrix A? How to construct the matrix A? All of you understood? Aij is given, I minus j is the equation. So what is the first element here? A11. All of you know. So in the next slide I will write that once again. A is equals to, what is the matrix is given? A is the Aij. A is equals to Aij with order is 3 by 3, where Aij is equals to I minus j. Then what is the matrix A? Yeah. So if it is a 3 by 3 matrix, how many elements you will get? 9 elements. Let us write the 9 elements as A11, A12, A13, A21, A22, A23, A31, A32, A33. Yeah, what is the result of this one here? Yeah. 3 by 3 matrix. 1, 1. Substitute 1, 1. I value is 1, j value is 1. 1 minus 1, 0. Sorry, 1 minus 1 is 0. This is what? 1 minus 2, minus 1. I value is 1, j value is 2. 1 minus 3, this is minus 2. What is the A21 here? I value is 2, j value is 1. 2 minus 1 is 1. 2 minus 2, 0. 2 minus 3 is minus 1. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. Hope all of you understood how we are constructing this matrix is using the equation Aij is equals to I minus j. So this is clear to all of you. Aij is equals to I minus j. So sometimes one more equation they will give it to you. Yeah. A is equals to Aij. So what is the purpose of explaining these examples is the significance of IJMN. Aij order 3 by 3, where Aij is equals to I into j. Aij is I into j. Then what is the matrix here? Yeah, if you observe here, so what is the matrix we are going to get? First element is what? A11, 1 into 1, I into j. 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is a 6, 3 into 1 is a 3, 6, 9. So these are the two examples which explain the significance of what is IJMN. Hope all of you understood, right? So any confusion, please clear. Hope all of you are understanding. Anybody is having confusion, right? So this is a significance of IJMN notations. Yeah, coming to next, in the types of matrices, first matrix is a row matrix. row matrix. Yeah, sometimes some definitions appears very simple for you, but 30 different types of matrices you have to study in depth. They are all very useful also. Row matrix. A matrix, what is its definition? A matrix whose order is a single row and n number of, whose order is 1 by n, single row and n number of columns. N belongs to positive integer. N belongs to positive integer. This n belongs to positive integer. Example, matrix is 1, 2, 3. What is the order of this matrix is 1 by 3. How many rows we are having here? Single row and columns are the 3 columns. Single row and 3 columns. N is what? Positive integer. Here I am going to give some introduction about the number systems because of positive integer is involved here. As all of you know, natural numbers are from where to where? Natural numbers 1, 2, 3 up to infinity. If 0 is added to the natural number, then it is what? Whole numbers. Whole numbers and negative numbers. Whole numbers and negative numbers are what? Integers. Integers represented by z. Z plus is positive integer, z minus is a negative integer. And integers and fractions. Integers and fractions are what? Integers and fractions are rational numbers q. Rational. Q means what? Rational. And rational and irrational. Rational and irrational. If you mix the rational and irrational combined, it's a real. Rational and irrational is a real. And real and imaginary. What is the combination of real and imaginary if you are combining? That is the complex. Complex numbers. So this sequence of numbers you should remember. Natural numbers are 1 to 3 infinity. 0 is added whole numbers. Whole numbers and negative numbers are the integers. Integers fractions are rational. Rational, irrational are the real. Real and imaginary is a complex. Some of you are getting the doubt why you are discussing this school level topic here. But sometimes it is required. Simple concepts also you have to revise. N belongs to positive integer here. Okay, that is about row matrix. If you are taking the column matrix, what is the result here? Column matrix definition. Column matrix. A matrix whose order is m by 1, where m belongs to again positive integer. If you are taking the example for the column matrix 1, 2, 3, what is the order of this matrix? Is the 3 by 1. So there is no restriction in the number of rows. Columns must be only 1. That's called the column matrix. So this example is clear to all of you. Row matrix, column matrix. Then a rectangular matrix. What is a rectangular matrix here? Rectangular matrix. M is not equal to n. A matrix which satisfies M is not equal to n. What does it mean? M represents what? Number of rows. Number of rows not equals to number of columns. Number of rows not equals to number of columns, then it is a rectangular matrix. Example, if we are taking 1, 2, 3, 4, 5, 6. What is the order of this matrix? It is a 2 by 3. M is not equal to n. So that is about the rectangular matrix. And if you are taking the square matrix, what is a square matrix? Example here, square. So a matrix which satisfy M is equals to n. M is equals to n. Example here, M is equals to n. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a square matrix. M is equals to n. M is equals to n square matrix, and this is also a best example of singular matrix. This is also best example of singular matrix whose determinant is 0. Singular matrix, what is the definition? Determinant is 0. You can remember a lifelong. What is the definition? What is the best example of singular matrix? You can remember. What is the best example of singular matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. Determinant is 0. Yeah, here one shortcut I am going to explain how to calculate the determinant. Please concentrate. Determinant, one shortcut for 3 by 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Write matrix as it is. These two columns revise. 1, 4, 7, 2, 5, 8. Revise. These two columns repeat here. These two columns repeat. Then what is the determinant of this one? What you have to do here now next? Yeah. These elements, these diagonal elements multiply. What is the multiplication of this? It's a 45 plus these diagonal elements multiply. Yeah, this is what? 84. Yeah, these elements diagonal multiply 96. 3, 4, 8. This diagonal. Yeah, don't get any confusion. So diagonal elements are multiplied. Yeah, this is a one best shortcut for calculating the determinant value. Then next minus of next diagonals, observe here. 753, 753. So what is its simplification is a 105 plus this is what? 861, 48. These three, this diagonal multiply 72. See what is the result we are going to get. This result is what? Here it is the, yeah, this is a 225. Overall it is what? 225 minus 225 equal to 0. So in this square matrix, I explained so many logics here. Square matrix exam, what is the definition of square matrix? Number of rows equal to number of columns. This is the best example. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the best example of the singular matrix also. What is the singular matrix? Determinant is 0. And how to calculate the determinant of any 3 by 3 matrix? This logic is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. And first two columns repeat. 1, 4, 7, 2, 5, 8. And first observe here, don't take the wrong diagonals. First this diagonal, like this diagonal, and then next diagonals, and take the subtraction. Hope all of you understood. This logic is also very important. That is about the square matrix. Then next null matrix definition. Null matrix. So you try at home how to calculate the determinant by taking another 3 by 3, some other 3 by 3. So expand this shortcut method also. Null matrix. As all of you know, Laplace expansion for any row, any column, determinant value remains same. That approach you know very well. This is a one shortcut approach which is helpful in your GATE exam. Null matrix. What is a null matrix? A matrix which contains all elements as zeros. A matrix which contains all elements as zeros. That is a null matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0. And there is no restriction in the order of the null matrix. Null matrix can be any order. Null matrix, it can be any order, no problem. Right? That is about the null matrix definition. So till now, what are the types of matrices we have discussed here? Row matrix, column matrix, rectangular matrix, square matrix, null matrix. Next one is very, very important definition. So principal diagonal. What is another name of the principal diagonal is called leading diagonal. So principal diagonal, leading diagonal, both are the same. What is the definition of the principal diagonal, leading diagonal? every square matrix contains two diagonals. Every square matrix contains two diagonals. Then principal diagonal is the one. Principal diagonal is the one. Principal diagonal is the one which contains elements. Which contains elements aij, which contains elements aij for all I is equals to j, which contains elements aij for all I is equals to j. That is the definition of the principal diagonal. Another name of the principal diagonal is also called the leading diagonal. If you are taking the example here, 1 2 3 4 5 6 7 8 9, this is a 3 by 3 matrix, square matrix. For this one, what is the principal diagonal here? For this one, what is the principal diagonal? Which is the principal diagonal? If you observe here, 1 5 1 5 9, this is the principal diagonal. Why it is called principal diagonal here? This row number column number is the same here, 1 1. This row number column number is also same, 2 2. This row number column number is also the same, 3 3. Actually this square matrix has the two diagonals. What are the two diagonals in this square matrix? Another diagonal is what here? Yeah, this is 3 5 7. These two diagonals, in these two diagonals, which one is called the principal diagonal? What is the red shaded? That is the principal diagonal. Another name of the principal diagonal is called the leading diagonal. The second diagonal is called off diagonal, OFF, off diagonal. So all of you are aware of the principal diagonal definition, leading diagonal. So coming to one important definition here, trace. What is the definition of the trace here? Trace definition, trace. Sum of all principal diagonal elements. Yeah, trace definition. Yeah, sum of diagonal elements. Yeah, very good. Sum of all principal diagonal elements. Sum of all principal diagonal elements. Sum of all principal diagonal elements is called the trace. In this example, what is trace? In this example, if you are calculating the trace, 1 plus 5 plus 9, 15 is the trace. In this example, 15 is the trace. So let us discuss the properties of the trace. Very important properties. Properties of the trace. Very important properties. First one, if you are taking trace of A transpose, trace of A. If you interchange the rows and columns, what happens here? Trace remains the same. Interchanging rows and columns, trace remains same. Second property, trace of Ka, trace of Ka, K into trace of A, trace of Ka, K into trace of A. Third property, trace of A plus B, trace of A plus B, trace of A plus trace of B, trace of A plus trace of B. Fourth property, trace of A minus B, trace of A minus B, trace of A minus trace of B. So all properties are very very important. You may expect direct properties also in the GATE exam. Yeah, fifth property, yeah, trace of null matrix is 0. Null matrix means all of you know 0 0 0 0 0 0. All principal diagonal elements are what here? All are the zeros. Trace is also 0. Trace of null matrix is 0. Next, sixth property, trace of unit matrix of order n. Yeah, can anybody guess what is the trace of unit matrix of order n? Please respond. What is the Trace of unit matrix of order n. Yes. Trace of unit matrix of order n. Yeah, trace of unit matrix of order n is the n. Yeah, some of you are responding. Yeah, trace of, if you are taking the 3 by 3 unit matrix, what is the trace 3 by 3? 1 0 0 0 1 0 0 0 1. What is the trace of the 3 by 3 matrix is the 3. If you are taking the 4 by 4 unit matrix is the 4. N by n trace of the unit matrix is n. Trace of unit matrix of order n is n. Seventh property. Trace of AB is equals to trace of BA. Eighth property. Trace of ABC. Trace of ABC is equals to trace of ACB. Trace of BAC. Trace of BCA. And also equals to trace of CAB. Trace of CBA. These all 8 properties are very, very important. So whenever we are saying properties means what, you may expect that straight questions from the properties. That's very important. So that is about the trace of the matrix. Then coming to next, is clear to all of you. Trace is cleared. Principal diagonal trace. The next type of matrix here, upper triangular matrix. Upper triangular matrix. See, today most of the session it is going with the concepts and some numericals also. So after completion of types of matrices, all concepts we will discuss all numericals. Upper triangular matrix. Upper triangular matrix. A matrix, upper triangular matrix. Yeah. All elements below principal diagonal are the zeros. Yeah. A matrix which contains all elements below principal diagonal or zeros. A matrix which contains all elements below principal diagonal or zeros. If you are taking the example here for the upper triangular, example 1 2 3 0 4 5 0 0 6, that is the upper triangular matrix. 1 2 3 0 4 5 0 0 6. See, in terms of Aij, you can write Aij is equals to 0. Observe, this condition is very important. A matrix which satisfies Aij equal to 0. Aij equal to 0 for all. You see here, what is the relation between I and j here? Row number is 2, column number is 1. Row number is 3, column number is 1. Row number is, for this element, row number is 3, column number is 2. For all I greater than j, observe this one, Aij equal to 0 for all I greater than j. You may get this question in the GATE exam, like Aij equal to 0 for all I greater than j. What type of matrix it is? The upper triangular matrix. So that is the upper triangular matrix. Then coming to lower triangular matrix. Next one, it is the lower triangular matrix. Lower triangular matrix. Yeah. Lower triangular matrix. So concepts, you have to clear the concepts first of all. Lower triangular matrix, a matrix which contains all elements above principal diagonal as zeros. If you are taking the example here, 1 0 0 2 3 0 4 5 6. Yeah, what is the condition here? Aij is equals to 0. Aij is equals to 0 for all What is I and j values here? I value is 1, j value is 2, I value is 1, j value is 3, I value is 2, j value is 3. For I less than j, aij is equals to 0 for all I less than j. What type of matrix it is? A lower triangular, upper triangular, lower triangular matrix, then diagonal matrix. See what the topic is going. The little bit patience is required. You have to listen all the types of matrices also. So this is the types of matrices are there, about 30 different types of matrices are there, one by one matrix. We are discussing what is its definition and condition, and we will solve the problems also, numericals also. Diagonal matrix. What is the diagonal matrix? A matrix which satisfy aij is not aij equal to 0 for all, aij equal to 0 for all, I is not equal to j, aij equal to 0 for all, I is not equal to j. If you are taking the example here 1 0 0 0 2 0 0 0 3, this is example for the diagonal matrix. See non-principal, all non-principal, you observe that aij equal to 0 for all, I is not equal to j. I is not equal to j means what? Non-principal diagonal, all elements must be zeros, and principal diagonal element, they may or may not be zeros. Here a is equals to, another example, 1 0 0 0 2 0 0 0 0 also you can take as a diagonal matrix, and like this 1 0 0 0 0 0 0 0. These are all the different examples of the diagonal matrix here. What is the condition here? Non-principal diagonal elements must be zeros, and principal diagonals, they may or may not be zeros. That is about the diagonal matrix. See, so till now what are the types of matrices we have done? Row matrix, column matrix, square matrix, rectangular matrix, lower triangular matrix, upper triangular matrix, diagonal. Then next scalar matrix. What is the definition of the scalar matrix? Scalar matrix, what is its definition? So aij is equals to k for all I is equals to j, and 0 for all I is not equal to j. If you are taking the example here k 0 0 0 k 0 0 0 k, so that is a scalar matrix. K may be any value, you can take k value 1 1 1 2 2 2 3 3. If k is equals to 1, if you put k is equals to 1, what is the result we are going to get? 1 0 0 0 1 0 0 0 1. Then what type of matrix it is called? The unit matrix. What is the name of this? Is called unit matrix. Unit matrix. Another name is called identity matrix. Unit matrix, identity matrix. Unit matrix, identity matrix. That is a scalar matrix. Unit matrix also scalar matrix. One more thing, remember that scalar matrix are, all scalar matrix are what? All scalar matrices are diagonal, but all diagonal need not be scalar. Just 1 minute. What is the relation between the scalar and diagonal? All scalar matrices are diagonal, but all diagonal need not be scalar. Yeah, coming to next. That is about the scalar matrix, diagonal scalar, unit matrix. Then coming to transpose matrix. What is a transpose matrix? Transpose matrix. A matrix obtained after interchanging the rows and columns. If you take A is equals to 1 2 3 4 5 6 7 8 9, what is its A transpose? Interchange the rows and columns. A transpose is what? 1 4 7 2 5 8 3 6 9. This is A transpose. If A is equals to Aij, if A is Aij, A transpose is what? A transpose contains Aj. Remember, this is very important. If A is Aij, A transpose contains what are the elements? Aj, Aij, Aj. That's about the transpose matrix definition. After interchanging the rows and columns, whatever the matrix we are getting, that is called the transpose matrix. Now properties of the transpose matrix, very very important. Properties of the transpose. Properties of transpose matrix. Properties of the transpose matrix. First one is, yeah, A transpose whole transpose. A transpose whole transpose is a A. Second property is Ka whole transpose. Ka whole transpose is K into A transpose, where K is the constant, where K is the constant. So no effect with the constant K. K remains as it is, right? Third, A plus B. A plus B whole transpose is equals to A transpose plus B transpose. Fourth, AB whole transpose. AB whole transpose is equals to B transpose into A transpose. Yeah. A inverse whole transpose is equals to A transpose whole inverse. All these five properties are very very important. It's this type of this is a previous gate question. If you observe this AB whole transpose is B transpose into A transpose is the previous gate. All five properties of the transpose matrix are very very important. Coming to next symmetric matrix definition. What is symmetric matrix? Symmetric matrix. What is the condition for the symmetric matrix? A transpose is equals to A. So this condition also a previous gate. Direct conditions also they are asking in the gate exam. A transpose. After interchanging the rows and columns, if the matrix remains same, then it is called the symmetric matrix. For the symmetric matrix, what? Aij with order 3 by 3 is equals to what? Aji. Aij both are equal. Aij, Aj both are equal, then it is called the symmetric matrix. Remember, like this also condition. Taking the example, if you are taking the example for the symmetric matrix, what is the example for the symmetric matrix here? A is equals to 1, 2, 3. This is 2, 3, 4, 5. You take the A transpose of this one here. A transpose remains as A only. For this matrix, A transpose is again A only. So this is the one example for the symmetric matrix. And next example, if you are taking here 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. So this is also another example of the symmetric matrix. These two examples of the symmetric matrix. In both the cases, it satisfies A transpose equal to A. What are the maximum number of elements we are having here? What are the maximum number of elements here? 6 elements are there. 6 maximum. Here how many maximum number of elements are there? 10 maximum number of elements. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maximum elements are 10. Maximum elements are 6. If you are taking n by n matrix, for n by n matrix, maximum number of elements, maximum number of distinct elements, maximum number of distinct elements is equals to n into n plus 1 by 2. So remember this formula. For n by n matrix, maximum number of distinct elements in the symmetric matrix, n into n plus 1 by 2. So remember, this is also very important formula. First thing is what? Condition of the symmetric matrix, examples, and maximum number of distinct elements n into n plus 1 by 2. For 3 by 3 matrix, if you put 3 by 3 matrix, 3 into 3 by 3 matrix is what? 3 into 4 by 2. That is a 6. What are the maximum number of distinct elements for the 3 by 3? 6. And if you take the 4 by 4, what are the maximum number of distinct elements? You will get the 10. And also next one is very important, formula to calculate the symmetric matrix. What is the formula to calculate the symmetric matrix? All the points are very important. Formula to calculate symmetric matrix. Formula to calculate symmetric matrix. What is the formula to calculate symmetric matrix? Symmetric matrix is equals to half A plus A transpose. Half A plus A transpose. We can write A plus A transpose also. 2 into A plus A transpose. So these are all comes under the symmetric matrices. Formula to calculate the symmetric matrix. Basically we are using the half A plus A transpose for any given matrix. Let us take one example here. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is the symmetric matrix for this question? Symmetric matrix is half into A plus A transpose. What is the A here? 1, 2, 3, 4, 5, 6, 7, 8, 9 plus A transpose. A transpose is what here? 147. 147. Interchange the rows and columns. 258, 369. What is the result of symmetric matrix here? Symmetric matrix is equals to 1 plus 1 is 2 by 2 is 1. 2 plus 4, 6 by 2, 3, 1, 3. Yeah, 3 plus 7, 10 by 2, 1, 3, 5. This is the 3, 5, 7, 5, 7, 9. So after applying half of A plus A transpose, whatever the resultant matrix, so that's going to become a what is called type of symmetric matrix. Yeah, this is the previous gate question. A plus A transpose is what type of matrix? It's the previous gate. A plus A transpose is what type of matrix? It's a symmetric matrix. Yeah, remember all the points about symmetric matrix: condition, examples, what are the maximum number of distinct elements, what is the formula to calculate the symmetric matrix, all are very, very important. Yes, any confusion, please clear. Hope all of you are following. Yeah, opposite diagonal elements are the same. See, above, listen. 3, 5, 7, 3, 5, 7. Upper triangular side, above the principal, below the principal diagonal, mirror image. It's clear. So hope everybody is following. No confusion. We are going with the medium speed only. So try to concentrate. So if you are attempting this time 2025 GATE exam, attempt seriously. Right. Next, skew symmetric matrix. What is the definition of the skew symmetric? Very important. Very good. So I'm expecting answer from all of you. Everyone respond. Be interactive. It should be interactive session. It should not be one way. Right. Yeah, anybody? How many of you are saying that condition for the skew symmetric? Anybody? We'll see how many of you will respond to skew symmetric. Few members are responded condition. Anybody? Skew symmetric. All of you are studied in the matrices first year and second year maths. Okay, right. Coming to skew symmetric matrix. Skew symmetric. Yeah, correct. A transpose equals to minus A. Very good. Yeah, skew symmetric. See, in my lecture, every day you will get lot of important points. That is sure. So my experience, I taught more than 500 batches for the gate. So you keep it that in your mind. Some of you are maybe not serious in the gate. Some of you are very serious. Take seriously in the preparation of the gate. That's your life settling exam also. Skew symmetric matrix. What is the condition for the skew symmetric matrix is A transpose is equals to minus A. Okay. Then examples if you are taking here, A transpose is minus A. The another way of you can write here, if it is a Aij 3 by 3, Aij 3 by 3. If A is Aij 3 by 3, A transpose becomes what? Minus Aji. Aij is equals to, yeah, minus A. So that is A transpose, what is called A transpose equal to minus A. Yeah, coming to example, if I taking 0, 1, 2, minus 1, minus 2, 0, 3, minus 3, 0. That is one example. Second example here, 0, 1, 2, 3, minus 1, minus 2, minus 3, 0, 4, 5, minus 4, minus 5, 0, 6, minus 6, 0. There's two examples here. Right. What are the important observation? If you observe here, all principal diagonal elements must be zeros. One important observation here in these two examples. Principal diagonal elements are zeros. Observe, that's very important point. Principal diagonal elements. See, if you take the A transpose, it satisfies A transpose equal to minus A in both the cases. All principal diagonal elements must be zeros. And what are the maximum number of elements we have here in this example? Yeah, can you guess what are the maximum distinct elements? Maximum distinct elements are how many? Maximum distinct elements. In this example, how many maximum distinct elements are appearing? In this example, what are the maximum distinct elements here? Maximum distinct elements. Yeah. What are the maximum distinct elements here? 1, 2, 3, minus 1, minus 2, minus 3. 3 plus 3, 6, and again 0, 7. In this case 7. Here how many maximum distinct elements are the 13? And for n by n, matrix, here is what? 1, 2, 3, 4, 5, 6, 1, minus 1, minus 2, minus 3, minus 5, 6, 6, 12, and 0, 13. For n by n matrix, yeah, for n by n matrix, what are the maximum number of distinct elements? For n by n matrix, for n by n skew symmetric matrix, remember n square minus n plus 1. N square minus n plus 1, that is a formula. N square minus n plus 1. Remember, this is n square minus n plus 1. You see here for 3 by 3, how many are there? 9 minus 3. 9 minus 3, 6 plus 1, 7. And for 4 by 4, 16 minus 4, 12 plus 1, 13. So remember that for this is a formula for n by n. What are the important points here? First one, all principal diagonal elements must be zeros. All principal diagonal elements 0. Yeah, mirror image not exist. Okay. All principal diagonal elements 0. And second point here, it is the, yeah, if you are taking maximum number of distinct elements, maximum number of distinct elements is equals to n square minus n plus 1. Maximum number of distinct elements are n square minus n plus 1. And the determinant value of skew symmetric matrix with odd order is equals to 0. Determinant value of skew symmetric matrix with odd order is 0. If you are taking example here, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 0, 5, 6, 7, minus 5, minus 6, minus 7, 0, 8, 9, minus 8, minus 9. If I'll ask you what is the determinant of this one, direct answer, determinant is 0. This is very important point. Determinant value of skew symmetric matrix with odd order. What is the order of this one? Fifth order, 5 by 5. Determinant value of skew symmetric matrix with odd order is always 0. That's very important point. And fourth one is formula to calculate skew symmetric matrix is half A minus A transpose 2 into A minus A transpose and so on. So these are all the formulae to calculate the skew symmetric matrix. All these formulas are applicable to calculate the skew symmetric matrix. Okay, if you are taking one example for how to calculate the skew symmetric, for the matrix A is given, A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. What is its skew symmetric matrix? All of you try. What is its skew symmetric matrix? Try this skew symmetric. Skew symmetric matrix for this one. Yeah, what is the formula for the skew symmetric matrix is equals to half A minus A transpose half into 1, 2, 3, 4, 5, 6, 7, 8, 9 minus A transpose 1, 4, 7, 2, 5, 8, 3, 6, 9. What is the result of this one here? Skew symmetric matrix. 1 minus 1, 0 by 2, it's a 0. 2 minus 4, minus 2 by 2, minus 1. 3 minus 7, minus 4 by 2, it's a minus 2. 4 minus 2, 2 by 2 is a 1. 5 minus 5, 0 by 2 is a 0. 6 minus 8 by 2, it's a minus 1. This is 2, 1, 0. So that is a skew symmetric matrix for the given matrix A. How to calculate the skew symmetric matrix for a given matrix A? Next. So one important point here. Every square matrix can be expressed. Note, very important note. Every square matrix can be expressed. After getting the result of this one, whether it is a skew symmetric or not, all principal diagonal elements are the zeros and it satisfies the transpose of this one, it is a minus A. That's also correct. Every square matrix can be expressed as every square matrix can be expressed as every square matrix can be expressed as sum of symmetric and skew symmetric matrices. Sum of symmetric and skew symmetric. A is equals to half A plus A transpose plus half A minus A transpose. What is the simplification of half A plus A transpose, half A minus A transpose? So it is again A only. You see here what is simplification here? A by 2, A transpose by 2, A by 2 minus A transpose by 2. A transpose by 2 minus A transpose by 2 cancel. A by 2 plus A by 2 is A. So very very important property. So let us discuss one previous gate question based on this property. Whatever the property we have discussed. One previous gate question. See, matrix P is decomposed into symmetric and skew symmetric. P is equals to S plus V. This is a matrix A is expressed as the sum of S is what? Symmetric. V is the skew symmetric matrix. S is given in our exam. S is given and V is given. Both are given. S is given and V also both are given. Then what is the P is asking? So what is the matrix S is given here? It's a previous gate question. S is given minus 4, 4, 2, 4, 3, 7 by 2, 4, 3, 7 by 2, 2, 7 by 2, 2, and matrix B is given 0, minus 2, and 3, 2, 0, 7 by 2, minus 3, minus 7 by 2, 0. So these are the two matrices are given and is asking what is the matrix P. Symmetric skew symmetries is given. What do you do to get the matrix P? So what is the logic here? S and V are given. We have to calculate P is equals to what? Sum of the symmetric matrix and skew symmetric matrix. Yes or no? Sum of the symmetric. P is decomposed into. Yeah. Actually it is given. Yeah. P is decomposed into. P is decomposed into S and V. S and V. What is the S here? S is a symmetric matrix. V is a skew symmetric. Then what is the P is asking? P is equals to how to calculate the P here? Sum of the symmetric and skew symmetric. Add both of them. What is the answer we are going to get? What is the P here? Summation of both the matrices. Minus 4 plus 0. It's a minus 4. 4 minus 2. It is a 2. 2 plus 3. 5. 4 plus 2, 6, 3, it's a 7, 7 by 2 plus 7 by 2, is minus 1, 2 minus 3, and it is a 0 and 2. That is the P matrix. P is what decomposed into the symmetric and skew symmetric. Symmetric and skew symmetric. So this is the previous gate question. You can apply easily. Everybody understood this question is clear? All of you confirm, please confirm, all of you understood. To attempt this question, we should have the knowledge about what is a symmetric and skew symmetric, and every square matrix can be expressed as the sum of the symmetric and skew symmetric. Yeah, very good. Hope everybody understood this question. Yeah. Yeah. If you are, most of your students are Telugu students, sometimes I will speak in Telugu also, no problem. Yeah. సో అందరికీ ఫాలో అవుతున్నారు అనుకుంటున్నాను. స్పీడ్ మీడియం అనే ఉంటుంది, ఫాస్ట్ టైం లేదు. యా, కమింగ్ టు నెక్స్ట్ వన్, ఆర్థోగోనల్ సిమెట్రిక్ స్క్యూ సిమెట్రిక్ కంప్లీటెడ్. నెక్స్ట్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్, ఆర్థోగోనల్ మ్యాట్రిక్స్. ఇస్ వెరీ వెరీ లాట్ ఆఫ్ గేట్ క్వశ్చన్స్. ఆర్థోగోనల్ మ్యాట్రిక్స్. What is the condition? A square matrix A is said to be orthogonal if A into A transpose A is equals to I. So that is the condition for orthogonal matrix. And what are the different properties we have here? Properties of orthogonal matrix. Properties of orthogonal matrix. What are the different properties of orthogonal matrix we are having? First one is what? Determinant of orthogonal matrix plus or minus 1. Very very important. That is a previous gate question only. Yeah. Determinant of orthogonal matrix is plus or minus 1. Second is A inverse is equals to A transpose. Orthogonal matrix A inverse is A transpose. These two are very very important properties. Totally 3 conditions are appearing on the slide here on the screen. This condition is orthogonal properties. Both are previous. All the 3 are previous gate. No doubt. All the 3 are previous gate. And if I are taking the example of orthogonal matrix, here I am explaining one example. A is equals to sin theta minus cos theta sin theta. So this is one example of orthogonal matrix. Whether it is orthogonal or not, we have to check. A into A transpose is I or not. What is the A here is given? Sin theta minus cos theta sin theta, and it's multiply with the A transpose. What is A transpose here? sin theta cos theta minus cos theta sin theta. What is the result we are going to get? A into A transpose. Sin square theta, yeah. Sin theta into sin square theta plus cos square theta. Yes. Yeah, that is a, yeah, unit matrix. Yeah. What is the result here? Yeah, sin square theta plus cos square theta is the 1. Sin theta cos theta minus cos theta sin theta is 1 0 0 1 you will get here. Cos square theta plus sin square theta 1 0 0 1 is what here? It is a I. Sin theta minus cos theta sin theta, one example of the orthogonal matrix. So some more examples I am going to write here. Second example, cos theta. Just I am interchanging the rows and columns here. Yeah, sin theta. First, this is the sin theta, cos theta, sin theta, cos theta, minus cos theta, sin theta. This is also orthogonal matrix. And one more orthogonal matrix is what here? Cos theta minus sin theta, sin theta, cos theta. This is also one example of orthogonal. And one more example also you can write easily. No need to by heart the examples. Cos theta, sin theta, minus sin theta, cos theta. Also example of orthogonal matrix. Just observe how I am writing the examples of all orthogonal matrices. See, what is the condition for orthogonal matrix? A into A transpose into A equal to I. For any matrix to check the condition of orthogonal, what you have to do here? Yes, A into A transpose into A. Don't check the only determinant. Determinant of A is plus or minus 1. It doesn't mean that it's orthogonal always. Okay, coming to what are the other examples we can write here? 1 0 0 0 0 cos theta minus sin theta cos theta. Like that we can write so many examples of orthogonal also. See, 1 0 0 0 0. Yeah, these 4 elements we can substitute all these 4 matrices in these 4 elements. 1 2 3 4 matrices you can substitute in these 4 elements, no problem. That is orthogonal. And the next examples also you can write here 0 0 1 0 0, and all 4 matrices you can substitute here. What are these 4 matrices? 1 2 3 4. All these 4 also substitute, that also gives the orthogonal. And you can write one more example also 0 0 1 0 0. Here also substitute all 4 by 4. So like that so many examples you can write here. A is equals to, so one more is there, so that is what 0 0 1 0 0. Here also substitute 4 by 4, all 4 matrices. So many examples you can give for the orthogonal matrix. So that is about orthogonal matrix condition example, right? See, one previous gate question I am going to discuss here about orthogonal matrix. Yeah, please concentrate about orthogonal matrix. One important question. This is a straight question in the 2018 gate paper. Straight gate question 2018. For an orthogonal matrix, the valid equality is, for an orthogonal matrix, the valid equality, for orthogonal matrix, the valid equality. So option A is given like this: Q transpose is Q inverse. Option B, Q is equals to Q inverse. For orthogonal matrix Q, the valid equality Q equal to Q inverse is given, B option. C option is given Q transpose equal to Q, and D option is given determinant of Q equal to 0. These are the A, B, C, D options are given. What is the correct answer? Which option is correct? Yes, tell me. All of you please respond. Which option is correct here for this question? Yeah, yeah, all of you respond. Everyone try to respond. Everybody is understanding. Yeah. What is the condition? If it is an orthogonal matrix, if it is an orthogonal matrix, what is the correct answer? For an orthogonal matrix Q, the valid equality is Q transpose equal to Q inverse. Q transpose is equals to Q inverse. Hope all of you understood. Still anybody is having confusion, please clear. Yeah, coming to next question is also previous gate question. Yeah, everybody understood? Okay, very good. See, what is my intention to say? If you remember the properties clearly, the answer is easy here. Properties, only directly property. That's why there is a lot of importance for the properties. Remember, all properties are very, very important. Next question. For the given orthogonal matrix, orthogonal matrix given like this Q. Q is given orthogonal matrix 3 by 7, 3 by 7, 2 by 7, 6 by 7, minus 6 by 7, 3 by 7, 2 by 7, 2 by 7, 6 by 7, minus 3 by 7, that is a previous gate question. Orthogonal matrix is given. It's a 2017 gate. For the orthogonal matrix Q, orthogonal matrix. So this is the orthogonal matrix is given. For the orthogonal matrix Q, Q inverse is direct question. Q inverse. What is the answer? Q inverse, direct question. Just take the transpose of this. 3 by 7 minus 6 by 7, 2 by 7, 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7, minus 3 by 7. Just we are taking the transpose of this one. See, if you don't know the property, Q inverse is Q transpose. So if you don't know this property, to calculate Q inverse, it takes lot of time using the formula adjoint Q divided by determinant of Q. This is another regular formula. It is our regular formula of the inverse, adjoint by det. If you are using adjoint by det, it takes a lot of time, even more than 20 minutes also. Adjoint Q by determinant of Q. So that's why my intention to say, remember, what is my suggestion? Remember all properties perfectly. You see here only orthogonal matrix, how much concept we have discussed. Condition for orthogonal matrix, A into A transpose A is I. What are the properties? Different examples. So many examples are there. For orthogonal matrix Q, what is the Q transpose is Q inverse. Determinant of orthogonal matrix is plus or minus 1. For the orthogonal matrix is given Q, what is the Q inverse? Q transpose. Yeah. So these are all different properties about orthogonal matrix. So till now, what are the different types of matrices we have discussed? What is a row matrix, column matrix, square matrix, rectangular matrix, principal diagonal, then upper triangular, lower triangular, diagonal, scalar matrix, unit matrix, null matrix, transpose matrix, symmetric, skew symmetric, orthogonal. So remember that what is the topic is going first of all, types of matrices. Yeah, some students they will take this topic as simple one, but this also disturbs your mind sometimes. You get it. Concentrate. Don't take this one as a simple topic. Concentrate. The easy topic only, but you have to study types of matrices also in depth. So coming to next, addition of matrices. Next concept is addition of matrices. Addition of matrices. That's also very important. Addition of matrices. Yeah, last question is clear to all of you. Last question, Q inverse is Q transpose. Everybody understood? Yeah, still any confusion, please clear. 7 and 7. Okay. Yeah, addition of matrices. Two matrices A and B. Two matrices A and B can be added. Two matrices A and B can be added if their orders are same. If their orders are same, order of the A must be equal to order of the B, then only matrices can be added. That point is well known to all of you. Yeah. What are the properties of addition of matrices? It follows A plus B equal to B plus A. What is this law? Is it commutative law or associative law? Yes, tell me. Is this commutative law or associative law? A plus B equal to B plus A is commutative or associative? Yeah, it is commutative law. Yeah, very good. A plus B equal to B plus A. It follows commutative law. This is commutative. It is associative. Addition of matrices follows associative also. Commutative law, associative law. Third property. Matrix A is there. To get the same matrix A, which matrix to be added? Matrix A is there. To get the same matrix A, which matrix to be added? Null matrix. This null matrix is called additive identity. Additive identity. Additive identity. What is the meaning of additive identity? A matrix to be added to the given matrix which results the same matrix. By adding the matrix to the given matrix, if the result is the same, A plus null matrix is the additive identity. Which matrix is additive identity? Null matrix. What is another name of the null matrix? Is called zero matrix. And fourth property, matrix A is there. To get the null matrix, which matrix to be added? Minus A. This minus is called additive inverse. Additive inverse. So what is additive and inverse? Minus A. Minus A is called the negative matrix. Negative matrix. These are the properties of the addition of matrices. Multiplication of matrices. What are the multiplication of matrices? Multiplication of matrices. Two matrices A and B can be added as AB. Two matrices A and B can be multiplied. Can A and B can be multiplied? Can be multiplied as AB. If number of columns in the A equal to number of rows in the B. So that is the condition is required. Number of columns in the A equal to number of rows in the B. So that is the condition is required for the multiplication of matrices. Yeah. Coming to, I am going to give some examples here. Tell me which is possible here. A is equals to 1, 2, 3, 4, 5, 6. B is equals to 1, 2, 3, 4. Which one is possible here? A is 1, 2, 3, 4, 5, 6. B is 1, 2, 3, 4. Whether AB is possible? AB possible? Option B. BA possible? Both possible? None of these possible. Yes, tell me what is your answer. Which one is possible? AB, BA? You understand the condition? Observe the condition. Multiplication of matrices. What is the condition? Number of columns in the A. Multiplication of two matrices A and B can be multiplied as AB. What is the condition? Number of, which is possible. Understand? this condition, number of columns in the A is equals to number of rows in the B. Using this condition, which is possible here, AB or AB, BA, which one is possible? To multiply AB, number of columns here is the 3, number of rows here 2. They are not equal. AB is not equal. To check the BA, number of columns here 2, number of rows here 2. Only BA is possible. Understand BA. For BA, what is the condition? Number of columns here 2, number of rows 2. BA is possible. What is the order of the BA? BA order. After finding the result of the B order is 2 by 2, B order is 2 by 2, A order is 2 by 3. What is BA order? We have to take this first one and this last 2 by 3. BA order is 2 by 3. BA order is 2 by 3. You are all understanding? B is 1, 2, 3, 4. A is 1, 2, 3, 4, 5, 6. After multiplication of BA, what is the resultant matrix? It is the 2 by 3 order. Hope all of you understood? Any confusion? Please clear. AB, BA, which is possible here? BA is possible in this case. Yeah. Coming to one more question I am going to give here. A is equals to 1, 2, 3, 4, 5, 6. A is 1, 2, 3, 4, 5, 6. B is equals to 1, 2, 3, 4, 5, 6. What the result is possible here? AB possible, AB possible, BA possible, both D, none of these. What is the result is possible here? What is the order of the A? Order of the A is 2 by 3. Order of the B is 3 by 2. Yeah. To get the AB matrix, what is the condition is required? To get the AB matrix, what is the condition? All of you understand? Number of columns here, number of rows, both are equal. AB is possible. Whether BA is possible or not, how to check whether BA is possible? B is what? 3 by 2. A is what? 2 by 3. Number of columns 2, number of rows 2. Both are possible here. AB and BA both are possible here. And what is AB order? After multiplying AB, what is the order? This 2 we have to take and this 2, 2 by 2. AB order is 2 by 2. BA order is what? 3 by 3 result you will get. 3 by 3. AB and BA. All of you know the condition for checking that AB and BA, we have to check the number of columns in the A, number of rows in the B. For BA also, number of columns in the B, number of rows in the A. AB, BA both are possible. Still any confusion? Hope all of you understood. Everybody understood? Any confusion? Please clear. Yeah. Next, if you are taking the matrix here, A order is M by P, B order is P by N. This is also very important. Number of multiplications in AB. After multiplying AB, how many multiplications we are getting? Number of multiplications in AB is M into N into P, and number of additions, this is also previous get. Number of additions is equals to M into N into P minus 1. Number of multiplications are M and P. Number of additions are Mn into P minus 1. That is also very, very important. So that is about additions and multiplications. Right. Properties of addition, multiplications properties. Properties of multiplications. Multiplication of matrices. Multiplication of matrices does not follow. Multiplication of matrices does not follow commutative law in general. Commutative law in general. Multiplication of matrices does not follow commutative law in general. That means here AB is not equal to BA in general. That is the word we are using here. In general. There are some cases where AB is equals to BA also. Some cases where AB equal to BA also. That's why you are using what is the word in general. Second, AB into C is equals to A into BC. It follows, what is the name of this law, is called associative law. Associative law. Third, yeah, matrix A is there to get the same matrix. Which matrix to be multiplied? Tell me. Matrix A is there to get the same matrix. Which matrix to be multiplied? Anybody? Which matrix to be multiplied? Can anybody guess? Yes. Anybody? Matrix A is there to get the same matrix A. Which matrix to be multiplied? Yeah, unit matrix. A into I. A into I is equals to A. This I is called multiplicative identity. Multiplicative identity. Fourth, matrix A is there to get the I matrix. Which matrix to be multiplied? Inverse. This is called multiplicative inverse. Multiplicative inverse. Multiplicative identity, multiplicative inverse. So these are the properties of addition of matrices, multiplication of matrices. So let us go to our next minor cofactor. Now what these are all very important. Minor cofactor, determinant, adjoint, inverse. So our next topics, coming topics are all, these are all minor, cofactor, determinant, adjoint, inverse, and the properties of all of them very, very important. Yeah, inverse. So after that, all these topics, inverse, determinant, adjoint, cofactor, minor. Then what are the other topics we have? What is idempotent matrix, nullpotent, involutory matrix? What is a singular matrix, non-singular, complex matrix, conjugate matrix, a conjugate matrix, Hermitian, skew Hermitian, unitary. So different types of matrices. After minor, cofactor, determinant, adjoint, inverse, what are the topics we have here? So idempotent matrix, idempotent, nullpotent, involutory matrix, complex matrix, complex, conjugate, conjugate matrix. Conjugate is what? A theta. Hermitian, skew Hermitian, unitary. So these are all the different types of matrices still we have. So what is the condition for the Hermitian? All of you know Hermitian is what? A theta is equals to A. Skew Hermitian is A theta equal to minus A. Unitary is what? A into A theta. A theta into A is equals to I. So these are all like Hermitian, skew Hermitian, orthogonal matrix, such kind of matrices only. Here coming to next one is what? Minor. Minor cofactor. How to calculate the minor for the matrix A? See, 1, 2, 3, 4, 5, 6, 7, 8, 9 is there. How to calculate the minor of 2? See here, minor of the 2. How to calculate the minor of the 2? Delete that row. Delete the row and column of that particular element. Rest of the elements 4, 6, 7, 9. How much is the determinant value? 36 minus 42 minus 6. That is the minor of the 2. If you want to calculate minor of 6, What is the minor of the 6? Minor of the 6. Delete the row and column of the 6. Delete the row and column of the 6. Rest of the elements. 1, 2, 7, 8. 8 minus 14 minus 6. So if you want to calculate the minor of the 7, minor of 7, how to calculate the minor of the 7? Delete the row and column of that particular 7. Rest of the elements 2, 3, 5, 6. 12 minus 15 minus 3. So these are all the different examples for how to calculate the minor. Yeah. Everybody studied this minor concept in your 12th and 11th, 12th standard. Then coming to cofactor. What is the formula for the cofactor? Minor cofactor determinant. Cofactor definition. Cofactor. Cofactor is equals to minus 1 to the power of I plus j into minor. Cofactor is minus 1 to the power of I plus j into minor. If I plus j is equals to even number, I plus j is even number. I plus j is a even number, then it's both cofactor and minors becomes the same. If I plus j is equals to odd number, cofactor is equals to minus into minor. So let us take one example, cofactor for this 5. What is the cofactor for this 5? Cofactor of the 5. Cofactor of the 5 is equals to what? Minus 1 power of. This 5 belongs to what here? 5 belongs to second row, second column. I plus j, 2 plus 2. And delete the row and column of that particular element, and rest of the elements are what? 1379. 1379. 1379. This is positive. 9 minus 21 minus 12. 9 minus 21 minus 12 is the cofactor of the 5. So like that you can calculate cofactor for all the 9 elements. Cofactor for all the 9 elements. That is about minor cofactor. Then coming to what is the adjoint matrix definition? Adjoint matrix. Adjoint matrix. What is the adjoint matrix is? Transpose of cofactors matrix. Transpose of cofactors matrix. Transpose of cofactors matrix is adjoint matrix. See, if A is equals to ABCD, A is equals to ABCD, adjoint A, this is also very interesting formula. Adjoint A is equals to D minus B minus C A. If A is equals to ABCD, what is the adjoint A? D minus B minus C A. That is the adjoint formula. Direct straight question also will be expected. They will give the question like this simply 1, 2, 3, 4. 1, 2, 3, 4. What is the adjoint of this one? Simple. Adjoint. Yeah, if you remember this formula, answer is easy. What is the adjoint of this one? 4 minus 2 minus 3, 1. So that is the adjoint matrix, right? Then next, if the 3 by 3 matrix is given, how to calculate the adjoint? I am going to give them some shortcut here, very important shortcut for you. Matrix A is given 1, 2, 3, 4, 5, 6, 7, 8, 9. One matrix is given. Already I told you it is a square matrix and also it is a singular matrix. What is the definition of the singular matrix is here? Whose determinant is equals to 0. Singular matrix whose determinant is 0. How to calculate the adjoint of this matrix? Adjoint A. Yeah, one shortcut, very important. Remember, how to calculate the adjoint of this matrix here? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Write as it is. And these two columns repeat as it is. 1, 4, 7. As you are done for the determinant shortcut, these two repeated. And again after that these two rows repeat. The colors also I am mentioning here. Observe how the changes are going here. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 4, 5, 6, 4, 5. Yeah. So after that, what you have to do here after writing? All of you understood how we are writing this one. So after writing all these things, delete this first row, delete this first row, and first column you delete. For rest of the elements, what you have to do here, adjoint. First 2 by 2. For this first 2 by 2, find the date 5689 date. What is the 5689 date? Find out. Yeah. What is the 5689 date? If you are observing here, 5689 determinant first. 45 minus 48 minus 3, and next to 6497 date. This is what here, 42 minus 36 is a 6. Yeah, this is what 42 minus 36, right? Coming to this one here, this determinant is completed. This determinant is completed. Now you take this determinant. What is the determinant of this one? 32 minus 30 minus 3. In the same way, apply the same logic for the this 8923. This is what, 24. 24 minus 18. It's a 6. Yeah, coming to next year, 9 minus 21 minus 12. 14 minus 8, it's a 6. Same way, this 3 by 3, 2, this 2 by 2. Now you take this 2 by 2. 12 minus, this is a minus 3. 6 minus 3. After getting this result, take the transpose. Transpose of this result is the adjoint for the 3 by 3. 3 by 3 adjoint, this is the logic. Once again observe. 1, 2, 3, the same matrix we are writing as it is. First 2 columns repeat, and first 2 rows repeat again here. Delete this first row and first column. For the rest of the elements, 2 by 2, 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 all. For all of them, take the determinant, and the transpose of this is the adjoint. Okay, generally they don't ask the adjoint of 3 by 3. 2 by 2 adjoint only frequently they are asking. Even if they are asking adjoint of 3 by 3, learn this shortcut. This is very much useful for you. Right, coming to properties of adjoint of the matrix. Very, very important properties. Properties of adjoint. Very, very important. First one, adjoint properties. So many gate questions on adjoint properties also. First property, adjoint AB. Adjoint AB is equals to adjoint B into adjoint A. Second property, so adjoint of A inverse, adjoint A whole inverse. Third property, adjoint of A transpose, adjoint A whole transpose. Third property. If you are observing fourth property here, determinant of adjoint A. This is very, very important. So many gate, this is very important. Determinant of adjoint A. Determinant of A to the power of n minus 1. Fifth property. So here A into adjoint A into adjoint A is equals to adjoint A into A. Determinant of A into I. This is also very important. A into adjoint, adjoint into A, determinant of A into I. Sixth property, adjoint of Ka, adjoint of Ka. K power n minus 1 into adjoint A. Keep the star mark for this one, very important. There is a scope to get the confusion in the exam. Adjoint of Ka, K power n minus 1 into adjoint A. Seventh property, adjoint of unit matrix is unit matrix. If you are taking adjoint for the unit matrix, it is a unit matrix only. Eighth property, adjoint of adjoint A, determinant of A to the power n minus 2 into A. Ninth, determinant of adjoint A, determinant of A to the power of n minus 1 whole square. Whenever I am saying properties of any topic, they are all direct shortcuts, direct questions will be expected. 10th one, determinant of adjoint of determinant of adjoint of adjoint of adjoint A, determinant of A to the power of n minus 1 whole cube. So these are all the different properties of adjoint, or around 10 properties are there. Every property is very important. Every property is very important here. Direct shortcuts also will be expected. So that is about adjoint. So the problems also I will discuss here. Related to here one question, if A is equals to Aij with order 3 by 3 matrix, determinant of A is equals to 2, then what is determinant of adjoint A? This is also previous gate question. What is the determinant of adjoint A? This type of question they will ask in the exam. What is the determinant of adjoint A? Then in that case we have to remember this formula immediately. Without knowing this property we cannot attempt this question. Yeah. What is the n value here in this case? N value is the 3. Determinant of adjoint A is equals to determinant of A to the power of n minus 1 whole square. What is the determinant of A here? 2. N value is the 3. 2 power 3 minus 1 whole square. 2 power of 4. So this is what? 4. 2 power 4. How much it is? 16 is the answer. Determinant of adjoint A, 16 is the answer using this property. Determinant of A to the power of n minus 1 whole square. For the same question, if they will ask the adjoint of adjoint A, sometimes they will ask the adjoint of adjoint A, what is the answer? So adjoint of adjoint A, what is the formula here? Determinant of A to the power of n minus 2 into determinant of A to the power of n minus 2 into A. What is the logic we have to apply here? Determinant of A to the power n minus 2 into A. All of you observe this property, adjoint of adjoint determinant of A to the power of n minus 2 into A. What is the answer here? Determinant of A is what here? 3. Determinant of A is 2. Determinant of A is 2. Power of n minus 2. 3 minus 2 into A. So 2A is the answer. This question is 16. Here it is the 2A. So this kind of questions they are asking in the this style, remember. And the same question if they will ask the determinant of adjoint of A. So one thing I want to say, remember the formula perfectly. Determinant of A to the power of n minus 1 whole cube. This is n minus 1 whole cube. Property, determinant of A to the power of n minus 1 whole cube. What is the determinant value here? 2. 2 power 3 minus 1 whole square. What is the result of this one? 2 power 2 square. It is a cube. 2 cube. This is cube here, please. Yeah. 2 power 8. 2 power 8 is the answer. 2 power is 16. 2 power 4 is 16. 2 power of 8 means what? 16 into 16 we can say. So that is 256 is the answer. Hope all of you are understanding. Please confirm. Everybody is following. All these type of questions are very important. Everybody is understanding. Yes, all of you understood these questions. Properties of adjoint. Anybody is having confusion? Please clear. Everybody understood? Yes. Yeah, coming to next to determinant. So what is the determinant and what are the different properties of the determinant? So determinant and properties of determinants also very important. What is the determinant definition? Yeah, determinant. Determinant. This is very lot of gate questions on the determinant, properties of determinant. The Laplace expansion determinant. The Laplace expansion about the Laplace expansion about any row, the Laplace expansion about any row or any column. So if you are taking here Laplace expansion about any row or any column, A11, A12, A13, A21, A22, A23, A31, A32, A33. So what is the determinant of this one here? Determinant is equals to A11 into A11 into cofactor of A11 into cofactor of A11, A11 into cofactor of A11 plus, see I am expanding the determinant for the first row, A12 into cofactor of A12 plus A13 into cofactor of A13. Is there any mistake in this formula? Anybody? Any mistake is there in this formula? So is there any mistake here? Anybody is identifying any mistake? Is there any mistake in this formula? No one is responding. Okay. This formula is correct only. Maybe some of you are thinking that it is a negative is required. So when you will get the negative sign here, if you are writing A11 into in terms of minor, minor of A11 minus A12 into minor of A12 plus A13 into minor of A13. If it is in terms of minors, you will find plus minus plus signs. If it is a cofactors, all are positives. Or determinant expansion, who was the mathematician invented? Laplace. Laplace invented this expansion. This determinant expansion is same with respect to any row or any column. So that is the determinant definition. What are the properties of the determinant? Very, very important. All properties. Properties of determinant, very, very important. What are the different properties of the determinant we have? First one, determinant of A transpose is equals to determinant of A. Second property, determinant of AB is equals to determinant of A into determinant of B. Third, determinant of A inverse, determinant of A whole inverse. Fourth property, determinant of Ka. K is a constant. Determinant of K power of n into determinant of A, where K is the constant, where K is constant, n is the order of the matrix. There are so many get questions in all these properties. Fifth one, determinant value of triangular matrix, determinant value of triangular, scalar, diagonal matrix. Determinant value of triangular, scalar, diagonal matrix is equals to product of principal diagonal elements. Product of principal diagonal elements. Product of principal diagonal elements. Sixth one, determinant of singular matrix is equals to 0. Determinant of singular matrix is equals to 0. 7. Determinant of non-singular matrix. Determinant of non-singular matrix is not equal to 0. It's not equal to 0. Eighth property, if two rows are similar, if two rows or two columns, two rows or two columns are similar, then what happens here? Then determinant is equals to, determinant is straight away 0. If two rows, two columns are similar, determinant value straight away 0. Yeah, coming to next property, ninth property, if two rows or two columns, two rows or two columns are interchanged, then determinant value remains same, determinant value remains same but sign changes, remains same but sign changes, that's very important. Value magnitude remains same but sign changes. That's about ninth property. So 10th property here, determinant of Ka1 B1 C1, Ka2 B2 C2, Ka3 B3 C3. See, if any row column multiplied, with the same constant, some constant k, then entire determinant also gets multiplied with the same constant. A1 B1 C1, A2 B2 C2, A3 B3 C3. So here this first column is multiplied with the k, entire determinant also gets multiplied with the k, same. 11th property, Ka1, Ka2, Ka3, LB1, LB2, LB3, MC1, MC2, MC3. See what happens here. First A1, A2, A3 is multiplied with the K, B1, B2, B3 multiplied with the L, C1, C2, C3 multiplied with the M. What happens here? Entire determinants will be multiplied by what? Is A1, B1, C1, A2, B2, C2, A3, B3, C3. Entire determinants multiply with what? K, L, M. K into L into M gets multiplied with the matrix. So that is about 11th property. And 12th property, in the last property, 12th property in the determinant, a determinant of A1 plus B1 C1 D1, A2 plus B2 C2 D2, A3 plus B3 C3 D3. So that is equals to what? If any row column is the sum of the two elements, that can be expressed as what? Sum of the two determinants, A1 C1 D1, A2 C2 D2, A3 C3 D3 plus B1 B2 B3, C1 C2 C3, D1 D2 D3. And if I'll ask you determinant of unit matrix, what is the determinant of unit matrix is 1. So these are the 13 properties of the determinant. Every property is very very important. So many gate questions on all the properties of the determinant. So after the determinant, what is our next one? It is the inverse of the matrix. And yeah, these are all the, what is the topic is going in all subtopics, types of matrices is going. So for our next completion of types of matrices, it takes more of an hour, 40-minute session. After the types of matrix, tomorrow rank of the matrix also will be closed. Tomorrow rank of the matrix also will be closed. You are all understanding what is the today's session types of matrices. Row matrix, column matrix, then a square, rectangular, upper triangular, lower triangular, then it is a diagonal, scalar, unit matrix, transpose matrix, symmetric, skew symmetric, orthogonal, different types, orthogonal matrix. Then it is the next properties of the determinant, addition of matrices, multiplication of matrices, adjoint matrix, cofactors, then minor properties of the cofactors, properties of the determinant. Whenever we are saying properties, they are all very very important, right? So hope all of you understood today's session. Any still any confusion in today's session? All of you are understanding? Tomorrow within first half an hour, 45 minutes, we'll close the types of matrices. So then rank also will be closed in the tomorrow's session, right? Hope everybody understood. Yeah, please confirm all of you are following. Everybody understood today's session. Please practice once again. Go through the videos. Any confusion? They are not responding. All of you understood now? Yes. So totally we have discussed so many concepts. Also go through that once again. Today's all the slides. Yeah, what is the syllabus? This is the syllabus of that types of matrices. Syllabus is going important notations, order, row matrix, column matrix, rectangular, square matrix, null matrix, principal diagonal, trace, properties of the trace, upper triangular, lower triangular, diagonal, scalar, transpose, and properties of the transpose of the matrix, formula to calculate the symmetric matrix, skew symmetric, properties of skew symmetric, formula to calculate every square matrix can be expressed as the sum of the symmetric and skew symmetric. So orthogonal matrix, properties of orthogonal matrix, addition multiplication of matrices, minor, cofactor, adjoint, what is the shortcut to calculate the adjoint, properties of the adjoint matrix, determinant, properties of the determinant. Yeah. Thank you. So we'll meet in tomorrow's session. Hope all of you understood today's session. Thank you.